Hey Geometry, this lesson is entitled Properties of Parallel Lines. We're just going to start off with one vocab word here to begin with. So what is a transversal? A transversal is a line that intersects two other lines at two different points. So notice here we have, this would be our transversal. Whoop, sorry about that. This would be our transversal right here. And notice it crosses the two lines at two different points. So you cannot have that yellow line crossing the other two lines at the same point. So that would make it a transversal. It intersects at two different points. Okay, now what we're going to talk about mainly today is different pairs of angles and the properties about them. So the first set here I have are 1 and 8. Now we're going to describe these angles by their location. Okay, so if you look at 1 and 8, we have to first determine, are they on the same side as the transversal, or are they on alternate sides of the transversal? So again, we have angle 1 and angle 8. And if you notice, they're on alternate sides of the transversal. Okay? Well, not only that, but are they on the interior of your two lines, or are they on the exterior? So basically, are they in between the two lines? On the outside. So in this case, they are exterior of the two lines. So therefore, the name of these angles are alternate exterior angles. Again, they're on alternate sides of the transversal, on the exterior of the two lines that the transversal is crossing. Okay? So again, we're going to label them, we're going to classify them by their location. Now 3 and 6. If you look at 3 and 6, 3 and 6 are also on alternate sides of the transversal. So these two angles right here. Let me make that a little clearer here. Okay. Angles 3 and 6. So this angle and this angle. They are on alternate sides of the transversal, but this time they're on the interior of the two lines. So therefore we would call these two angles alternate interior angles. Okay, again, alternate sides of the transversal, interior between the two lines that the transversal crosses. Okay, now 1 and 7, you'll notice they are on the same side of the transversal, but on the exterior. So, therefore, these are called same side exterior angles. Now notice I just abbreviated exterior just for sake of room. But again, 1 and 7 are on the same side of the transversal. They're both on the left side. And they're on the exterior of the two lines that the transversal crosses. Okay? Now here we have 4 and 6. 4 and 6, notice they're also, again, same side, but this time they're on the interior. That are in between the two lines. So obviously, we're going to call these same side interior angles. Okay? So again, same side of the transversal, and in between the two lines, so therefore they're same side interior angles. Now there's one more actually not here. Let me go ahead and throw that on there as well, but it's a very important one. So now we have angles 2 and 6. Now, so far we've talked about alternate interior exterior, same side interior exterior. Well, another type of angle would be angles 2 and 6. Notice 2 and 6, they're both on the same side of the transversal, but they're neither both on the exterior, both on the interior. So there's a name for that. If you have two angles that are on the same side of the transversal, but they're also in the same position just from one line to the next. Again, so we have this line right here. And notice angle 6 is in the upper right of that line. And then this line right here, angle 2, is also in the upper right. If they're in the same position, just on a different line, they are called corresponding angles. Okay? Again, corresponding angles are when they're in the same position, if you view it as like quadrants, but just on a different line. Okay? Now, what do we know about them? Well, what happens if these two lines that the transversal is crossing through are parallel? Okay, what if those two lines are parallel? What happens to these angles? Well, the corresponding angles, Okay, if we were to measure this angle, angle 2 and angle 6, actually let's do it as the example is asking, 1 and 5. Notice here's obtuse, notice here's obtuse. Now, I don't necessarily have the tools to do this, but on this app. But if I were to take this line right here, and I were to shift it all the way up to this line, you'll notice that angle 1 and angle 5 are actually the same degree measure. So, what we can say is that corresponding angles are congruent. Okay, if the two lines are parallel, then the corresponding angles are congruent. That's not the best congruent symbol. Okay, corresponding angles are congruent. Not that much better. Anyways, alternate interior angles. If you look at 3 and 6, okay, 3 and 6, you'll notice also here that they're both acute. But if I were to take just a picture of that amount right there, and I were to rotate it 180 degrees and line it up with angles 5, 6, 7, and 8, we would actually see that those two angles, 3 and 6, are going to be the same value. Okay? They're the same value. Now there's ways to prove this, which we'll get to, regarding supplementary angles and vertical angles and all that stuff that we've already done. But for now, I'll just let you know, and again, we'll get to the proofs later, that alternate interior angles are also going to be congruent to each other. Okay? Alternate interior angles are congruent. Now let's get rid of this. Now the next one we have, I'm messing up our diagram, is angles 2 and 7. What do we know about alternate exterior? Again, well, if 3 and 6 are congruent, and 2 is vertical to 3, so we know that 2 and 3 have to be congruent because they're vertical. We know that 6 and 7 have to be congruent because they're vertical. And now that we said 3 and 6 are congruent, 2 and 7, by the transitive property, would have to be congruent as well. Okay? So 2 and 7. So alternate interior angles, alternate exterior angles, and corresponding angles, they're all going to be congruent to each other. Okay? So 2 and 7 are congruent, 3 and 6, and 1 and 5. And our last two is, now I put SS, INT, that means same side interior. So same side interior angles, so 3 and 5. So we have 3 and 5. Now notice 3 is an acute angle, 5 is obtuse. So they can't be congruent. An obtuse angle and an acute angle, there's no way they can be congruent to each other. Well, let's think about this. We've said that 1 and 5, since they're corresponding, are congruent. But notice that 1 and 3 are supplementary because they're a linear pair. Well, if 1 and 3 are supplementary and 5 is the same thing as 1, then we could say that 3 and 5, the same side interior, those are going to be supplementary as well. Okay? So those are I'm just going to type it out. So those are going to be supplementary. Okay? So they're going to add up to 180 degrees. In like manner, when we look at angles 1 and 7, if you look at 1 and 7, again, also obtuse, acute. Okay? Now, we have 1 and 7, we have 1 and 7, obtuse, acute. Now, if these two lines are parallel, that means 1 and 7, same side exterior angles, are also going to be supplementary. Okay? So, to recap, this is the main thing about this section. Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary. Same side exterior angles are supplementary. Now what we're going to do is we're going to apply that to a couple problems here. This first problem. Now if you know that two lines are parallel. Now here we have two sets of parallel lines crossing each other. All you need is one value, one measurement, and we can find all of the angles that are created. So we see here that this angle is 50 degrees. So we go off of what we know. We know that 50 and 8 are vertical. So we know that angle 8 is 50 degrees. Now, 7 and 50, angle 7 and 50 are supplementary. So therefore, they have to add up to 180. So if this angle right here is 50 degrees, angle 7 must be 130 degrees because they need to add up to 180. The good thing about this part is that once we know one angle, or actually once we know two angles, one acute, one obtuse, we know that all the angles actually have to be matching one of these two values. So in this example, all the obtuse ones are going to be 130, all the acute ones are going to be 50. Okay? So, but just for the sake of justifying each answer, let's talk about that. We already said that this 50 degrees, again, and angle 8 are vertical, that's why it's 50. 8 and 7 are supplementary, that's why 7 is 130. Now notice angle 6, notice these, if you look at this sideways, okay, if you can view it sideways, we have 7 and 6 here. I probably shouldn't do the same marks. Those are going to be same side interior, and we said same side interior add up to 180 because they're supplementary. So if angle 7 is 130, angle 6 has to be 50. 6 and 2, those are supplementary. So if 6 is 50, we know that angle 2 has to be 130. Let me rewrite that. I don't want you to confuse that with a 30. It's 50. Now here, if you look at 50 and angle 5, if these are the two lines you're talking about, making line C your transversal, 50, this angle 50 and angle 5 are alternate interior angles, which we said those are congruent. So therefore 5 would also have to be, 5 would also have to be 50 degrees. Again, notice that all of them are either 50 or 130 if the lines are parallel. So from here, if we know angle 5, angle 1 is vertical to that, so we know that's 50. Now we can look now at angle 1 and 3. Notice 1 and 3 are supplementary. Okay, why? Because they are same side interior. Sorry, I'm like making a lot of marks here. If you look at line C and line D, B being your transversal, you'll notice that 1 and 3 are on the same side of line B and in between D and C, therefore same side interior, which we said they're supplementary. So if 1 is 50, 3 has to be 130. And lastly, 3 and 4 are vertical, so that would be 130 as well. Okay? So again, really all you need is one value, one of these angles, because then you can find the one that's supplementary to that. And all of these angles have to be either the obtuse angle or the acute value. Okay? Now, if we have a picture here we have a diagram. Find the values of x and y in the diagram at left. All we're given is that this line here and this line here, by the way, these markings, these red arrows, no, I'm covering it with yellow, that means they're parallel. Okay, I forgot to mention that earlier in the video. Those arrows mean, and I'll erase it so you can see it, those red arrows means that these two lines are parallel. Okay? Therefore, if that's true, then this is your transversal. Okay? That's cutting across those two lines. So the question is, what is x and y? Now, the common mistake is to look at this and say, well, y has to be 70 because it's an isosceles triangle, but we don't know that. It doesn't tell us that. But what we have to go off is what we've learned. We know that these two angles technically are corresponding angles because those are, again, parallel lines. Well, we noticed that we discussed earlier that corresponding angles are congruent. So x in this case would have to be 70 degrees. Again, if this one is 70, x has to be 70 as well because they are corresponding. Now the question is, how do we find y? Well, all three of these angles right here create this one line. And one line is 180 degrees. So we know now that x, which is 70, plus the 50, plus y has to equal 180 degrees because it makes a straight line. So now we combine them. So it's 120 plus y is equal to 180. And now we need to get y by itself, so we're going to subtract 120 from both sides, leaving us with 60. So there you go. We have x is equal to 70, y is equal to 60. Okay? Again, we have many different types of angles that we're talking about, but we can't forget the ones we learned in the past too, like supplementary and vertical angles as well. Let's do another one here. Find the values of x and y, then find the measures of the angle. So we have two sets of directions. Find the values, find the measures. So first, let's find the values of x and y. How do we do that? Well, we're given here technically a trapezoid because we have one set of parallel lines, but even without knowing the specific name of this quadrilateral, we do know one thing. We know that these two lines are parallel to each other. So if I'm going to look at x, I notice that this would be my transversal then. Okay, this line, this side going straight up and down is our transversal. Well, this 2x and this 90 degrees right here, those are on the same side of the transversal in between the parallel lines. So therefore, these two angles are what we call same side interior. And we said before that same side interior angles are supplementary, so they add up to 180. Okay, now we get x by itself, so we have to subtract the 90. Divide by 2, and you get 45. X is 45. And now let's look over at y. So we turn our focus over to the other side. Here's our transversal, okay, intersecting the two parallel sides. And notice that these two angles, okay, this angle here and this angle here, are also on the same side of the transversal interior. Okay, so those two, so y, let me use a brighter color. We have y plus y minus 50 is equal to 180. Okay, so we combine like terms. I'm going to go ahead and add the 50 over. So that gives us 230. Divide by 2, we get y is equal to 115. Okay, so here goes our x, here goes our y. Now that's the first set of directions, but it also says find the measure of each angle. Well, we know the bottom left is 90 degrees. 2 times 45, so the top left is 90 degrees. The top right is just y, so that's 115 degrees. And then the bottom right is 115 minus 50, so that would give us 65 degrees. Now if you want to check your work, a four-sided polygon, four-sided figure is called, has a 360 degrees on the inside. So if you were to add these up, you should get 360 if you did this correctly. Okay? But that's how we do these. Please just take it one step at a time. And the most important thing is to remember these types of angles right here. And what, again, are they congruent? Or I don't even know what that is. I was trying to do a little bracket. Are they congruent or are they supplementary? Okay? All right, well, good luck with that. And please ask questions if you have any.